Okay, over to you, Soby.
Thanks, Joanna. Hello, everyone. Welcome to this session where we'll try to explain some of the uh, thought process behind why we need to refactor the current context management library in TFA and some of the design principles we are trying to achieve. And yeah, Zelalem will further go down into the details of how some of these changes will be done in code. So a brief introduction into context management. So EL3 is responsible for switching the worlds between, say, non-secure and secure. And when CCA is introduced, we would have a realm world also involved. So EL3, which would be in its own world called root world, would now be in charge of switching between three worlds: non-secure, secure, and realm. So the context management library in TFA provides some basic helper routines for initializing the context for each world, and also to switch them, to save and restore them. So the BL3 one maintains separate context, CPU context for each world, which is initialized during cold boot. The CPU features which need to be enabled for a particular world are initialized in the context during the cold boot time. So, for example, if the non-secure world wants to use floating point and it wants to use SVE, then the appropriate trap bits in EL3 system registers need to be disabled. So all those kind of feature enablement would need to be done by BL31 for each world. And at runtime, based on the SMC, if the SMC is targeting the secure world, then BL31 will do the required save and restore of the CPU context for transitioning from the non-secure world into the secure world. So yeah, and when we have realm world involved, similar process, but this time it's between non-secure world and realm world. Now, due to the gradual evolution of this library over time, the current state of the library is a bit of a maintenance hazard, and it is prone to programming errors. So I'll go into some of the details in the next slide. So the agenda, as we already mentioned, is to discuss the overall design direction on how to refactor this library. So one thing to keep in mind here is some of the details of the design may undergo further refinement if if the implementation shows difficulties. So this design is more like a high-level design thought. When we actually get down to implementing it, if we find there are certain difficulties, we might change some of these details. So yeah, so this slide is discussing some of the design principles for the context management library. So the first one is the current context management library. It has a centralized API. So if you're already familiar with the TFA code base, there are APIs called CM context init and then CM setup context, which are initializing the context for each world. So if we look at the current CM setup context, which hopefully, yeah. So hopefully you can see the browser window. So that's the CM setup context currently implemented in TFA. And I've highlighted the security state variable. And as you can see, depending on the security state, there's various operations happening within that function. Sorry. Yeah. So if it is non-secure, then the corresponding SCREL3 for the non-secure context should have 80A bit set. Similarly, if it is secure, then there is a separate set of registers to be initialized. And this function has grown over time, and it has become a very huge function, managing several settings for two worlds initially and now three worlds, which makes it a bit of a maintenance hazard because anytime you want to change a setting for the particular world, we have to modify this particular function, and we need to be aware of all the other settings that are being done. One of the main goals of the refactoring is to move to a decentralized model. So in the decentralized model, it would be up to the world dispatcher. Each world, the secure world has got a dispatcher component. The realm world would have its own dispatcher component. And the dispatcher component is now responsible for all the initialization for that particular world. So this moves away some of the uh, world-specific initialization from CM setup context into the dispatcher component responsibility. Now, one thing to be aware is the non-secure world does not have a corresponding dispatcher. So we would need to do a special helper function just for the non-secure world. Yeah. The second principle. Yeah.
Sorry, quick question. Sorry to interrupt. So is this already implemented or is this in the works?
This is in the works. Yeah. So this is, we would, no, I'm just, we are trying to discuss the overall design direction for refactoring context management. Zelalem has started prototyping some of the code changes, but none of the code changes are complete, or it's not, yeah, it's not in a working state as of now.
Okay, thank you.
The next principle is EL3 should only initialize the immediate used lower EL. Now, in the current context setup, CM setup context, we can find there are some register initialization corresponding to EL1. Now, this most likely is an artifact of legacy. There is a special configuration for the non-secure world to skip EL2 and run the non-secure world directly from EL1, but that's a special configuration. But other than that, when we have secure EL2 and when SPM is running at secure EL2, EL3 initializing any EL1 values would probably be redundant because it's likely that SPM would come around and initialize the correct values for secure EL1 anyway. So so second goal is, EL3 should only worry about initializing the immediate lower EL. Now, there is a special case when you switch world, it may be necessary to restore EL1. This is mainly to prevent leakage of EL1 register context from between the worlds. Now, SPM is already taking care of all the EL1 non-secure. It makes sure that EL1 context is not being leaked. Then possibly we can remove this EL1 restore from EL3, but we need to go into the details how whether all the code paths for entering SPM and coming back takes care of restoring the non-secure EL1 context. If that is the case, then EL3 doesn't have to deal with EL1 context at all. The third point is this is related to feature enablement for each world. So currently, the way features are enabled for a particular world, it's a mix of CPU context and direct register access. So for example, certain features are enabled for a particular world via the CPU context library, whereas certain other features, it's enabled by just directly writing the global system register. And every time a world switch is detected, the global system register is modified. So this means we have two different patterns of managing feature enablement between worlds, and that's probably likely place for errors. So what we are saying is if features need to be managed separately between worlds, make it part of CPU context library. And once the CPU context is initialized for that particular world, the save and restore of the CPU context will take care of setting the right EL3 sysreg for that world. So the good news is this is the pattern more or less followed, but there are exceptions in the code, and we just need to make sure we just follow one pattern of doing this.
Do you have an
Yeah.
example of an exception? I was SCR EL3 and ELR EL3. Those things are already part of this pattern, right? I assume that's what you're thinking of.
So
what are the
so previously SVE enablement used to be done directly by writing to CPTR EL3 directly. It was not part of CPU context. So what happened is when we go into non-secure world, the Z bit in CPTR EL3 is disabled there, so as to disable the traps for SVE register access. And then when a transition to secure world is detected, the same register is directly accessed to set this bit so that the secure world cannot access SVE. So this was the pattern existing a couple of months ago. Now there has been a refactoring done to move CPTR EL3 to CPU context library, which means that is now resolved. So this point is just calling out that if there are any such patterns still existing in the code base, we need to move it to the CPU context library, and any future feature management between the worlds should make use of CPU context rather than manipulating the register directly within EL3.
Thanks.
Soby, does it mean that we will have to introduce different build options with features for different worlds?
Right. So that's a good question. So the thing to be aware of here is if we need to differentiate feature enablement between the different worlds, then we would need to have separate build flags anyway. As in, if we were to control SVE enablement separately between non-secure and secure, we would need to have two different build flags anyway. Now, doing this doesn't really add a problem, because the problem of having different build flags, if you wanted to control them separately, is already there. But doing this allows you to perhaps optimize or remove some of these build flags by allowing the dispatchers to detect capability more dynamically. So that's the fourth point, where SPMD, for example, if it knows that SPM can manage SVE properly, then we don't need a build flag in TFA to control SVE feature for secure world, because SPMD is tightly coupled to SPM, and it knows that SPM can enable or detect SVE and do things dynamically, in which case SPMD can check the ARC feature register, and if SVE is present, it can directly go and enable it. And we may not necessarily need a build flag to control it. So what I'm saying,
what happens to pivot, for example, in this case? Are we enabling for all worlds, or are we disabling for some worlds, enabling for other worlds? And they'll have to store and save and restore the pivot re-register on switching.
Right. So we need to take it on a feature by feature basis. Pioth is special because all the four worlds would probably need it enabled. Even EL3 uses it for itself. So currently, I don't fully know how Pioth is being enabled via build flags in TFA, but I would think that yeah,
there is a flag which specifies BTI options, and one of the options just enables pivot for all BLs.
Correct. Yeah. So I would think Pioth is a feature that needs to be enabled for all the worlds, and if EL2 doesn't want to use it, it's a choice left to EL2 for that particular world to make use of it or not. So in this case, yeah, you just control it using one build flag and then enable Pioth for all the worlds involved from EL3. Disable the trap for Pioth if there is such a trap. Yeah.
Is a typical example because the keys are stored in _EL1 system registers. It means
Yes.
EL3 using poff needs to update EL1 registers. So I guess that's one exception to the rules.
Yes. So when pauth feature is being used by all the 4 worlds, EL3 as part of switching the world or even entering EL3 should take care that it should save the appropriate key registers, restore its own keys to those registers, execute EL3, and as part of exiting EL3, it would need to restore the keys of the particular world into those EL1 registers, into the EL1 registers. Yeah. So yeah, that's part of enabling a feature from EL3. Yeah.
Okay, thank you.
In general, it seems like, well, I don't think you'll need per world flags, right? It's the build flag serves, I guess, at least 1 or 2 purposes, right? One is to reduce code size as well, and then to enable disable features, both at compile and runtime. So I guess I didn't understand why you were thinking you'd need per world, defines or flags, build flags.
The example can be AMU registers and PMU registers, for example, and maybe debug registers.
So you just need to enable and disable it in EL3. And then, if one world uses it, then you have to save and restore all the registers, right? Anyway.
Yeah, but when you go to another world, what happens to these registers? You don't need them, for example. Do you need to set them to 0? What happens?
Yes, I imagine you would set them to 0, right? If one world enables it, you have to maintain isolation. So EL3 would have to maintain that isolation and set all of those to 0. And then everything else would be dynamic based on Arch features, right? By dynamically detecting it.
Yeah, the PMU is something in my mind is, if it's a 2-world system, non-secure and secure, it's unlikely that the secure world would make use of the PMU feature. So there is an option for EL3 to disable the trap just for non-secure and keep the trap for PMU enabled for secure, in which case you have 2 different settings to be applied to the PMU control register at EL3 between the 2 worlds. So if it's done in this way, what it means is EL3 doesn't need to save and restore, because what would happen is the non-secure is allowed to use PMU, but because the trap is enabled for the secure world would not be allowed to access those registers. So even if EL3 does not perform save and restore of PMU registers, secure world cannot access it because it would trap. So in that way, having an asymmetric enablement of feature allows EL3 to not save and restore in some cases, but this is not the common rule. We need to do it on a case-by-case basis. Yeah.
Okay, I see. Okay, so typically you wouldn't require per world flags, but some exceptional cases like this, it might help optimize if you have per world flags. Is that a fair statement?
Yeah. The other case is SME extension. So we had to do this recently for the SME enablement. Now, because SME registers are shared with SIMD registers, we could enable SME for non-secure, but since we keep the trap enabled for the secure world, what it allows EL3 to do is not save the SME registers, because SME registers are pretty huge. It's like 64 kilobytes, up to 64 kilobytes of registers that need to be saved. So enabling it only for the non-secure world and keeping the trap enabled for the secure world allows EL3 to not save and restore SME as part of the world switch, because secure world will never be able to use it. Yeah, so there are some cases where this is useful to have a separate build flag control.
Right. Yeah, makes sense. Yeah, I think it will be even more complicated when you add the extra world, right? You can have like 8 different combinations. So we have to be careful, or yeah, we have to be really careful, right? A mistake here means breaking isolation.
Yes. So that's one of the reasons why we are moving some of the world responsibility to the dispatcher. So this actually, now the dispatcher is aware whether that world can actually, whether the world needs the feature and whether it can actually manage that feature. And depending on that, the dispatcher can decide whether to save and restore when going into that world. Yeah, so it moves, it decentralizes the complexity a little bit. And yeah, it's easier for management.
Yeah, makes sense. Thanks.
Yeah, the fourth point was pretty straightforward. So we have one EL2 sysreg context save function, which, as you can see on my screen, is a big monolithic function which saves various EL2 registers corresponding to various features. Now, what this prevents is to do this dynamically, because these are all now controlled by build flags. And this prevents the SPMD to do this dynamically, because if the build flag is enabled, then EL3 would try to go and save and restore it anyway and hit the trap. So what is being proposed is, sorry. Yeah, so what is being proposed is break it up based on features. Instead of having one monolithic function doing everything, break it up into smaller functions. And this will allow in future, if dispatchers want to choose which ones to save and restore. The next slide is, it's introducing a new concept. We're calling it root context at the moment. So currently I mentioned that, for every world, there is a CPU context being maintained by EL3. But EL3 itself does not have a context of its own. Why is it needed? I'll try to explain using the current sequence implemented. So when we enter into EL3 from non-secure, EL3 would save the non-secure general purpose registers, and it would save the EL3, it would save the non-secure EL3 CPU context. And depending on the SMC, if the SMC is for SPM, it would get delivered to SPMD. And SPMD now decides to enter secure EL2, and it would save the non-secure EL2 context and restore the secure EL2 context. So it's so you can see that the non-secure EL2 context is not saved on entry to EL3, but it's kind of a deferred action being done by SPMD over here. And then the EL3 entry point would now would go into secure world. At this point, it would restore the secure general purpose context and the secure EL3 registers. The reverse would happen when coming back from secure. Now, the problem here is, as part of the CPU context, we have EL3 system registers, and the values that are being applied during EL3 execution are the values which correspond to the world that caused the entry into EL3. So during this execution here, the EL3 sysreg values would correspond to whatever was being programmed for the non-secure world. A typical example is, if non-secure world wanted SVE to be enabled, during this execution here, the CPTR EL3.Z bit would be disabled for this entire execution. And it's only during the entry to the secure world, any sysreg, any EL3 sysreg corresponding to the secure world would be programmed. Similarly, on the return path, all of this execution, the EL3 sysreg would correspond to values being programmed for the secure world. Now, this is not a big issue, but we think it's better for robustness and for a predictable execution environment at EL3, for EL3 to have sysreg values that it knows is needed for EL3 execution. So that's why this is being proposed, where EL3 itself has a root context. So as soon as you enter EL3, the EL3 sysreg context would be restored once the save of that particular sysreg is done. And then during this execution, we have a predictable and stable EL3 sysreg, whatever was programmed by EL3. And the problem is avoided because as soon as you come into EL3, we program a EL3 sysreg, which is corresponding to what is needed for EL3. Yeah, so doing this, yeah, as I mentioned, is better for robustness, and we haven't noticed any particular issue by not doing it, but we can't say for sure that this will not be a problem in future. So yeah, that's why we are introducing this root context concept. So this will need some prototyping to figure out what changes are involved and what is the overheads for doing this extra sysreg programming. And depending on the results of prototyping, yeah, we would need to make a decision.
So your root context would contain all the underscore EL3 registers and GP registers?
It would contain all the underscore EL3 registers, which are currently part of the CPU context and are being programmed separately corresponding to the settings needed for that particular world. So these are mostly the trap registers controlling various features. SCR-EL3 controlling the interrupt routing. And it would also contain some lower EL registers like pauth registers. That is more of a reorganization because EL3 itself needs to make use of pauth registers for enabling pointer rate authentication at EL3. So this would just do any sysreg that is needed for EL3's own execution would be part of this EL3, this root context, and it would get programmed on entry to EL3.
Okay, so you would save all of those off into the current executing world CPU context, then restore the EL3 root context.
Yes.
And then
Yes, yeah. So some more details are, I pushed out an RFC earlier this week mentioning all of these changes, and some details are, some examples are given why this might be a problem and what all specific registers yeah, that might be part of this root context. Yeah. So Zelalem will walk through some of the code changes involved as part of the discussion. Zelalem, would you like to?
Yeah. Yeah, can you hear me?
Yes, yeah.
Okay, yeah, so I'll just go through the specific changes that we are planning to do. So I guess the first change is, as part of the cleanup process, we might need to add more EL3 context registers, specifically regarding feature interrupts registers. So we expect to add a few EL3 registers. Also, I guess we discussed this earlier. So registers that don't need to have different values across worlds, we don't necessarily need to add them in the context. So we need to figure out those registers as well. So on AL2 context, so I guess today we have a few AL2 context registers that are only accessible from the secure state. So these don't need to be part of the context, right? Because they're not accessible by non-secure. So we can basically remove these registers. Yeah, so this is one task. Yeah, next slide. So, okay, so the second one is, I think Soby mentioned in the beginning that we want to move into a decentralized setup or initialization. So I think one thing we proposed is that, splitting up the same setup context function into, 4 functions. So we can have, we have common initializations for all words, so we can put those into one common function, and we can split the rest into like 3 functions. So we can have setup secure context, which is going to be initialize, secure state specific registers, and it will be used by the SPMD. And we'll have a similar function for the realm, which is used by RMMD. And we also have, we'll have a setup non-secure context, which will be used by the PSI library in BL3.1. So yeah, so this is splitting the same setup context. So we are planning to use, the same interface as same setup context. And I guess we have, legacy code. We have the ARC32 code, and we have code, that doesn't or setup configurations that doesn't have, SPMD or RMMD. So I think those legacy code can keep using the old same setup context. Yeah, so this is one change we are proposing. Next slide. Right, so the third change is regarding CM prepare L3 exit. So today we use, I think we use this function CM prepare L3 exit to, I guess when we first exit to non-secure world, we use this function. So this function is kind of a bit complicated. So it does 2 things. It does initialization as well as restoring. So specifically what it does is first it will, directly initializes AL2 registers for non-secure. So we have 2 cases. One for the case where we have non-secure AL2 or hypervisor mode, and for the case where we don't have AL2, right? We skip AL2 case. So in this case, currently it initializes registers directly, not through the context. It also enables features for non-secure case. So even this one, the enabling feature is also it's not consistent. So some of the features are initialized using the context registers, and the others are initialized by directly writing to the AL3 registers. So we need to clean this up. This is, I think, prone to error because we have this inconsistency where, sometimes we are using the context register, sometimes we are not using the context register. So the third thing that this function does is it will restore the AL1 context, and then it will set the erase context. So this is common. I guess next slide. So what we are proposing is we want to move, the initialization code to the setup function for the non-secure, which is same setup non-secure context. And we want to do, the initializations or initializations using the context registers. So this is, this way we can avoid, the error where we might have, some inconsistencies during initialization. So if we do this, what we can do is, instead of using, the old CM prepare L3 exit function, we can, do the initializations at the initialization stage. And at the point where we call this function, we'll just do register restore. So we can just basically, restore L2 and L1 system registers. So I guess in this case, I think Soby earlier mentioned that, normally we want the L3 register to only initialize, L2 registers, and we want the corresponding, secure realm model software to take care of L1 context. So I think we can do this case by case. For example, if the SPM, for example, can clear registers before it goes back to AL3s, and we can avoid restoring AL1. But currently this is just a a general sequence we have.
In theory, you could split this into prepare EL3 exit NS S and realm 2, right? Because is it possible to have non-secure EL2 but not secure EL2, and then have realm? I don't know if that's a valid configuration, right?
Yeah, you mean you have you have secure EL2 but you don't have realm? Is that the question?
I mean, I'm saying if you've got some wacky configuration like that, right, where you've got non-secure EL2 but no secure EL2, and you have realm, I don't know if that's legal. In which case, splitting to prepare EL3 exit NS S and realm might help in that case.
So I'm assuming, I think if you are in RME, I'm not sure, but you assume you have secure EL2, right? Am I correct, Soby?
Yeah, I think we are focusing the case where SPM is running at secure EL2 and RMM is running in realm EL2. There are various legacy configurations where secure EL2 may not be used, but I think we would try to keep the existing code as it is for the legacy cases, and we'll only focus on most of the refactoring for SPM running at secure EL2 and RMM running at REL2. Yeah.
Right. I mean, I guess the reason I'm saying this is it seems like one of the points is to avoid, saying if secure do this, if non-secure do this, right? And or if realm do this, like you showed in the function. So you want to make sure you avoid the same thing here as well, right?
Oh yes, that's true. Yeah. So I think NS is it's actually a pointer to the context memory itself. The function itself is not aware whether it's a secure world context or non-secure world context. It's not represented correctly. Yeah. So it's the argument NS is a pointer to a context buffer, and all the function will do is just blindly restore it. It doesn't care whether it is secure or realm or non-secure. Yeah.
Any other questions? Okay, yeah, I think we can go to the next slide. Yeah, so this is just to show you an example usage of the new proposed function. So this is for the PSCI CPU power down case, or during warm boot. So in the old or in the current flow, when we call PSCI suspend power down, what we do is we save the entry point information by calling the basically calling the setup context or initializing, and after powering up after the warm boot, we basically restore the context using CM prepare L3 exit for the non-secure. So this is for the non-secure case. So after we introduce this change, this flow will change into during the context save, we will replace this function with the common setup and setup for an unsecure context. And during warm boot, we will just do restore, right? We just restore the L2 and L1 system register. So we don't do any direct initialization of registers. Yeah, so this is just to show you what the new flow would look like. Right, okay, so the fourth change is, I think this is, straightforward, like Soby mentioned, CM L2 sys register context save and restore functions are, a long a monolithic function. Basically saves, so it calls L2 sysreg context save assembly function. So what you want to do is you just want to split this function into multiple assembly functions depending on or each for the specific feature. For example, we will have something like L2 sysreg context, some feature, and save restore. So if we do that, then SPMD and RMMD, depending on feature build flags statically, or they can dynamically check for enabled features, and they can call the corresponding functions. Yeah, so this is the first change. The last change, like Soby mentioned, we plan on prototyping the root context that Soby mentioned earlier. So I guess we still have to identify, which registers we, should be part of this root exe context, and we also need to evaluate the impact on, binary size and SMSQL response latency. And yeah, depending on the result, we will, take it forward. Yeah, so I guess that's it. So if you have, any questions, any comments?
Zelalem, is there an intention to keep the original implementation? So there will be like a build option to choose what to use.
For which function or?
For this context management. So are you going to completely remove the old implementation and switch to a new one, or keep the old one and provide the developer with the option to choose which option to implement?
Yeah, so so I guess like Soby mentioned, so we plan to keep the old implementation because we have legacy code. It would be hard to, at least we have to, I think for now we have to keep using the old ones for some of the configurations. And maybe we can, progressively move to the new implementation for all configurations. But for now, we are planning to keep the old code as well.
So this context management library is a library of functions, and what we are thinking is, both the old variant and the new variant will be implemented in the library, and depending on which functions are getting referenced, it will get included in the final binary. Now, SPMD and RMMD will migrate to the new variants, whereas any other dispatcher components like traditional trusted OSS or any other legacy code which is still referencing the old library functions, we'll probably leave it untouched. It's only SPMD and RMMD which will migrate to these new variants. Yeah.
Okay, thank you.
I have a question for Soby, perhaps Zelalem as well, on the item 4, which is providing individual CMD restore functions for each feature. I'm trying to convince myself in the sense that with the current implementation, the EL2 save and restore are symmetric. It means there is no way that we miss a feature one way, one way or the other, going from NS to S or secure to non-secure. because save and restore are crafted in the same way, where the exact same set of architectural features are saved and restored. And now, with dispatching individual little save and restore functions per arch feature within the dispatchers, I wonder if there could be some kind of asymmetry where the non-secure expects some set of feature to be saved, where the dispatcher in one or the other of SPMD and RMMD become asymmetric.
Yeah, so the only case a feature will not get saved and restored by the dispatcher is the feature is disabled for that world. And by disabled means suitable traps should be enabled. So if the traps are enabled, that means that particular world cannot access those registers anyway. And hence the dispatcher can be pretty sure that those registers will not be accessed by the world, and hence I don't need to save and restore during the world switch. So this way, I think if we enforce a rule that if some set is being left out, the dispatcher has to ensure that that particular feature is disabled for that particular world. None of the registers should be accessible in that world.
So does a trap imply that the feature is disabled? Is there no case where, okay, trap is for access, right? If you don't access it,
Yes.
Does that mean those registers will not influence execution as well? That seems logical, but I don't know.
We need to yeah, so if the registers have latent values from non-secure, and are you saying that even if secure world is not actually making use of that feature or trying to access those registers because it's got values programmed by non-secure, and even if the trap is enabled, it might influence something on the secure world.
Right. I mean, I don't know that that case exists, but I'm asking, right, or something to think about. Because a trap does not necessarily mean a feature is disabled, or does not necessarily mean it does not, may not necessarily mean it does not influence execution.
Right. So usually, as part of feature enablement, we disable the trap, and that's when the particular world will be able to even use that feature. So the assumption is if the trap is still enabled at EL3, the feature is unusable for all lower ELs. That's the assumption. So if that assumption is not holding true, then we need to reevaluate.
Right, like pack registers or something, right? Not saying this is the case. If you've got some keys from non-secure world, let's say the code is compiled with pack and it can use the keys, but it simply cannot change it, right? You can potentially have a policy like that.
Pack,
Which
yes,
says,
pack,
you shall not access the registers to change it, but it has values, so it can be used directly or indirectly.
Yeah, pack, I think there is no trap existing at EL3. It's more like I haven't seen a trap for pack.
Right.
So
yeah, I think that was just a made up fake example, right? I guess I'm saying there could be features like that.
Yeah, if there is no trap existing for that feature, then we have to do it save and restore. The only case where you could avoid saving a feature is when there is a corresponding trap, and yeah, that's what I think.
Right, and the statement is you could avoid it, right? But you may still, even if there is a trap, you could still need to save and restore if it influences execution.
Yes, yeah.
Okay.
So this is Yeah. So in some cases, there is certainly an advantage of not saving and restoring. For example, the SME and SVE, it's a huge context structure, or there might be a huge list of registers to save and restore. But if there is no big advantage in not saving a one register or two, I would, it's better to just save it and restore it anyway. Yeah, there's no point in doing it on a very fine-grained basis for every feature. Yeah. But this is just left as an option if we wanted to do something at the dispatcher level. So doing this refactoring will allow to do that optimization, but it's not essential that we do that optimization. If that's the intention.
Are there any more questions for the team? Doesn't sound like it. Is there any final things you want to say, Soby? Otherwise, we can complete the meeting.
No, that was it. Yeah.
All right. Thank you for everyone. I'll stop the recording now, and that will be published on trustedfirmware.org Tech Forum site soon.